Okay, so the next doubt persists. 1 mole of ideal gas is heated slowly so that it goes from the PV state. This is P1, V1, P2, V2. Fine. In such a way that the pressure is directly proportional to volume. So pressure is directly proportional to volume. So I can write P equal to some K. K is some constant. How much work is done on the gas in the process? Okay. So work done is integral PdV. Okay. So work done is integral PdV. So this will give me integral P is kV, some constant kdV. So this is equal to right. So let's do this. K comes out initial. Let's say V initial is, let's say I take this V and this is 3V. Let's just do it simply. So K comes out. So this will be integral V square. Let's finish it off. V square by 2 integral V to 3V. And here what you need to know is when you substitute the data, you should be clear that K has to be taken into account. Okay. So if I substitute for K, you need to understand when you substitute this, rather to make it simple, I'll write V initial, V final. Okay. So let me write it as this is V initial, V final. So V initial, V final. When I substitute, K is PV, right? So this is P into V cube by 2, V initial, V final. And remember, K goes together with P. So which means when I change V, P will automatically change. Appo K constant. So which means when I write V final, P should also be P final. So work done is P final, V final cube by 2 minus P initial, V initial cube by 2. P final is 3P. V final is 3V the whole cube by 2 minus P initial is P. This is V cube by 2. Obviously, I can PV cube by 2. I can take constant, common PV cube. So it is 27. Yeah, so 27 into 3, 81 minus 1. I hope this is clear. So this is 80 by 2, which is 40 PV cube. This is work done. And the important thing to remember, this is the work done by the gas, integral PdV. So here they want work done on the gas. So it is negative of it. Okay. So this is by the gas. So work done on the gas is equal to minus 40 PV cube. And when I say PV cube here, this is, what is that? P initial is P for me. Maybe I'll write P initial, V initial because they have not given me any values. Okay, this is done. And then they're asking, how was the temperature of the gas related to its volume during this process? And again, they said it's an ideal gas. So I'm going to use the ideal gas equation. This condition they have given. And also I know that PV is equal to nRT. So for P, I can write K into V. So K into V is nRT. So V square is proportional to T. This is the relationship between volume and temperature. Everything, assuming it's a closed container, because they said N is 1, I'm going to assume it remains constant. N is 1, R is constant, and K is a constant. So V square is proportional to T. This is the relationship. Hope this is clear. If you want to understand this better, watch the class videos in it. And in the 11th playlist, okay, completely available. It's for you. And if you have more doubts, you can post in the Telegram channel, link in the description. So keep practicing. If you have any other doubts, you can let me know. Okay, if you like the video, like the video.